So please, round of applause for Adam Mirko Boehm. Thank you.
Hello there. Welcome to the last session of the day, or as I'd like to think of it, the first part of the social event. I'm Till, the one with the hair is Mirko. It's quite easy to remember. We're both old. We don't remember it all the time, so we're both actually injured. He's got a bad knee, I've got a bad ankle. So there'll be no dancing, I'm sorry. I know some people got really excited about the prospect. Mirko is actually an economics lecturer at the university these days. I do mostly suit stuff, but we are actually, believe it or not, honest-to-God engineers, and we've both been doing Qt a long time. In the course of that, we've come across a bunch of stuff that people do. Not all of it pretty, not all of it as you would, if you do that kind of thing, you call up the support at DJR and you explain to them what you do, they'll say, get the hell out of here, that kind of thing. And we think there's, it's fun to look at these things, but there's also a little bit of a deeper truth potentially in all of this. So what we'll try and do is show you some interesting, fun stuff to laugh at other people's interesting ideas, and also dig a little bit as to what that might potentially mean. So at this point, I'll hand over to Mirko to give you a little bit of an introduction.
Yeah, welcome. Thanks for coming here. First, a little qualification to what Till said. I hope you're not here for what we put in a topic, because we're not going to be talking about that. So, yes, we're going to look at a few ways to use Qt that are unexpected, or that are surprising, or that come up after using Qt for a while. But we're also trying to put this in a larger perspective, in a context of why do we still work on these issues. So when we thought about this talk, the thing that we were puzzled with is that after years of using Qt, and I'm using Qt since '97, newbie, we're still discussing the same issues. We're discussing how to do threading. Did you see that we just rewrote documentation for QThread, for Qt5 again? We're discussing how to stream data. We're discussing what a SQL API should look like. And I think that if we would mark in our calendars when these topics have been discussed, it would be like a recurring thing over years. So they're the same topics that come up again and again. And what we're trying to do is, first, Till is going to introduce you to a couple of examples of things that we're still running into. And then we're going to try to categorize these and see, we're trying to find an answer for why are we discussing these issues again and again. And hopefully say something about the future of Qt, right? And we're also, we're going to show you mad skills in terms of presentation and visualization of data.
Yep. So yeah, first little nugget here. By the way, none of the stuff that we're showing we actually did ourselves. We were too old for that. In some cases, the guilty parties are in the room. I will perfectly, of course, point them out if that's the case. In this particular case, I don't know, David, are you here? No? What's the other one? All right, so this little nugget comes out of the Kdevelop project. It was conceived by one David Nolden, who's been around Qt a long time as well. And I'd like you to give you an introduction to that one. So here's the problem. You're thinking to yourself, I need to do something from a secondary thread that the documentation says I can only do on the GUI thread. Yeah. So reasonable people will tell you, just don't do that, right? Because that's a very, very bad idea. You know what the GUI thread might be doing at that point. Just don't. But you have an actual, honest to God, real good reason to do that, and maybe you have to deliver on time or whatever. So you're forced to kind of, do something from a secondary thread that you really should only be doing on the main thread. And of course, you're a programmer, so who's to tell you what to do or what not to do, right? Come on, you guys. Long day, eh? All right. So the solution for this. On the secondary thread, so I'm the secondary thread now, you're the primary thread, you kind of raise a flag, you want to do something on the main thread, right? This is, going on in parallel, so you have to wave your hand and say, I want to do something on the main thread now. And then you send a signal, you basically post an event to the main event loop by doing something like QMeta object invoke method with a Qt connection. So you basically put something in the main event loop, which then gets picked off, and until it's picked off, you're just sitting on a wait condition. So as to not busy spin, you could be doing something else, but let's just say you wait. And now on the primary thread, whenever you get out of the event loop, because that event is being picked off the event loop, you guys all know how signal slots across threads works, right? And invoke method with Qt connection, you're all cool with that, right? So eventually it gets picked off the, hey, this is the advanced track, come on. So eventually this gets picked off the main event loop. What you then do is you take a static object, which lives on the main loop, you lock a mutex on that, right? You tell the secondary thread that it's now okay to wake up and do whatever it needs doing, and you block. At this point, you should have, there's somebody with shivers down his spine, right? This goes against everything you've ever taught, right? If you've ever been in any Qt training of mine, certainly, I've said about it 17 million times you're not supposed to do that, right? Sometimes you just have to. So problem, of course, is this will block the UI, yeah. So basically, as long as you know it's fast, right? As long as you know it's just a few milliseconds, why the hell not? So you do something on the secondary thread, you know the main thread is blocked, so anything you would otherwise have to do on the main thread, you can now do in the secondary thread. If it doesn't take too much time, it'll be fine because you return to the event loop in time for the user to not notice that you did something really, really ugly. Believe it or not, there are actual real-world use cases for this kind of thing. And in QtDevelop, it started as one use case, which was basically managing ranges in the editor because they didn't want to keep the editor state outside the UI, again, to not have to synchronize it. So they needed to access something on the UI from the secondary thread, which was doing the layouting. And I'm told they have now found several more use cases for this because, you know, if you have a hammer. So, all right. Yes, not the prettiest thing in the world, I'm sure you'll agree, but, you know, a man's got to do what a man's got to do. Okay, different topic entirely. This was just to warm you up. SQL. Who has worked with QtSQL here? Yeah, you know, you come across the odd database, right? So QtSQL is one of those things, it's kind of okay. It's not particularly powerful. It's just basically a way to get SQL strings into a database, right? And a little bit of, yeah, it works with Postgres and it works with MySQL. But at the end of the day, you take a string and you dump it into the database and it's executed there. It doesn't give you a whole lot. So that's a little bit, it's just copy and paste from the documentation because I'm lazy. Yeah, you've all used this, pretty much. So what's the problem here? It's not so bad, is it? Yeah, Andras, come on, you're a grown man. Stand up and shout. Strings, right? It's all strings. You have no type safety, no checking. You don't know if you're using column names that don't even exist, right? There's no error handling at all. It's all the good, you know, the whole SQL. Yeah, feels like that, doesn't it? So it's effectively what we've been doing in the 70s, right? String stuff. So
no, when he says we, he doesn't literally mean we.
Well, those of us who do not have hair anymore used to do this in the 70s. So, I'm looking at you, Sean Hammer. What would we like to have? Well, we would like to be able to say we want to create the tables, first of all, in some sort of automatable way, because the tables change, don't they? It's not this perfect world where you get the table layout and it's going to be like that forever, and you generate it once in your database, and lo and behold, the next 15 years you just write and read from. It's not that way. You add columns, you change table structures, things evolve, you need to do new tables, right? So wouldn't it be nice if that was automatable, so you don't have to, you know, if you do unit tests, you want to start from a clean database, you just want to start from scratch and generate the whole bugger. And ideally type safe, so you don't have to do it all in strings. And then it'd be nice if you could generate the queries and not have to do all the typing, because typing's bad and we get it wrong all the time, right? There's typos in the SQL all the time. It's not particularly safe either, right? Particularly when you get the strings from somewhere else, the internets. So we don't do that, do we? No?
Never.
Swear to God. Never. And then, I mean, it would be really, really, really nice if what we do is select, which is effectively, again, just putting a string into a database, we could actually do in the language we all love, which is, of course, oh, come on. Fortran. No, so we want to do this in C++, ideally even in Qt, right? With nice, big, strong type safe. C++, 11, all that good stuff. Strings are like totally 80s, we don't want them. So, enter Volker. Where's Volker? Yeah, there you go. So blame this guy for the next 10 minutes or so. So Volker came in across this and said, I can do better than that. So first of all, what you really want to do is you want to describe your database structure in a domain-specific language. In other words, you use a macro. That's just the, domain-specific language basically is a way of saying I'm going to use a macro. Okay. Well, you could. Oh, I'm sorry. You could use a different domain-specific language, preferably something XML or JSON or something, and generate your specification from that. But in this case, we chose to use macros because we had them lying around. Then you use template meta programming, of course, because otherwise, you're not one of the cool kids, and you get compile time checking, compile time type checking. And then, of course, you generate the actual QtSQL code, which is just fine because QtSQL does what it does quite well. It connects you to the actual database, puts the string down there, gets the result back, and all that good stuff. Looks something like this. That's the domain-specific language. You describe your structure, right? All the columns in your database. The syntax, again, is totally variable. Whatever you use to actually, describe this in some meaningful way that you can pass. And then you tell the C++ system what types you're actually using in those columns, because somehow we have to inject the types into this, right? So this is using boost MPL vector, which I'm sure you've all used exhaustively in the past. Yes? Mark? No? Okay, so that's a little bit, yes, it could be improved aesthetically, but, does the job. This table thing that I just showed you, our domain-specific language, that's a macro, looks something like this. Basically generates two things. It generates a type, and it generates kind of a dummy instance of that type. Theoretically, we'd only use the type because we're at template meta-programming level, so we're generating stuff at compile time. But if you want to have the nice, just pass an object to get the type inference, so you don't have to explicitly do the template stuff, you need an object to pass around for the type inference. So we create an object instance, and we use that to pass it around, make the syntax a bit nicer, because it's already awesomely nice, right? And we could do something like this. There's a method that actually generates the SQL. So at the end of the day, of course, this is still just QtSQL code that's being generated, all the usual good stuff. But we use a bunch of boost MPL, TMP stuff to actually look at what types we're dealing with and actually in a type-safe way check whether what we put into the queries is the right columns with the right types, right? Gone are the days of typos in the column names. We put on top something like this, query builders that basically give you a nice API for assembling queries, because concatenating strings is also like totally 80s, right? And of course, you want to be sure that you have the right stuff. Again, you're using the right column names. They actually exist as objects, as types. You have the right tables. They actually exist as types, and so on. So this will give you compile time errors if you use something that doesn't exist in the database, which is, of course, awesomely awesome, right? And then, of course, you can put some sugar on top if you're Volker and you have too much spare time, like combining queries into things and concatenating and having nesting and all of this good stuff. Not good enough, you say? It's cool, right? Come on, this is cool stuff. So, wouldn't it be cool if we could do select in C++? I'm just going to let this sink in. So this will actually not compile. Not only if you're using a column name or a table name that doesn't exist, but if you're referencing a type that wasn't actually existing in the previous part of the query, it's going to give you a compile time error. And you can't even see any brackets there. That's cool, right? And it actually works. Believe it or not, this is an actual real-life project that heavily uses databases, and it actually needs to be, it's medical stuff, so it needs to be very, very reliable about the way it uses the databases. And this saves lives, quite literally. It makes it much more secure. So, we'll leave the implementation details as an exercise to the reader, or you can kidnap Volker. Something completely different. Just to recover a little bit, right? So if you're a consultant, and many of you are consultants, come on, show your flag. Yeah. Well, we like to think of ourselves as serially employed. So if you have a customer that says, I want a QML UI, because QML is cool, but I also want a native iPhone UI, and I want a Metro UI and an HTML5 UI, and I want the whole thing, and it's supposed to look native on all the platforms, and Qt's not going to cut it, so you make me all these nice individual UIs, but you share all the code in the backend because that's the way we do things, right? And you then say very reasonably, of course, well, that's really not your problem, because I'm going to do all of this, and I'm not going to, tell you how I do this, because it's my special sauce magic, and you pay very good daily rates for me to do this. And then I give it all to you, and you don't worry about this. At which point the customer, of course, laughs you out of the building, because they want to give the iPhone UI development to somebody else, or maybe somewhere else. So they're never going to let you get away with this, okay, in the real world. So what do? Well, you give them an interface they can work with. You basically write a local REST or SOAP or something web service, which seems a little bit odd at first glance, doesn't it? Ever done this? Yes? Okay, who thinks this is unexpected? Okay, so you're actually, thank you. You guys are hard, come on. So yeah, basically what you're doing is you're pretending it's web development, right? Because that's what these guys do best. You run a local service and you think about your API, you expose it in a nice service-oriented, stateless, RESTful way, right? Which is cool because you want to run this on the server at some point anyway, right? Yeah, probably, maybe not. Well, the way things are going, who knows, right? We'll all be writing web services soon. And then, of course, you don't develop the iPhone UI. You wouldn't have been able to do that competitively anyway. And you leave it to the guy with the fixie bike who lives just down the street. I know a guy who lives literally down the street, rides a fixie bike, and writes iPhone applications. So this is not a joke. And he's good. And another one. So list views, right? Mirko was saying we put this in the abstract about modal view because people tend to show up to talks that say modal view and QThread. We've been doing this a while, you see. So yeah, there has to be something about model view in there. The bit about using model view from Qt as a view in the model view controller thing, we thought it was a cool idea. We actually do that all the time. Just use QAbstract item model, read only, and do all the other stuff in a separate controller and so on. Then we realized, well, that's really all there is to say about that. So there you have it. So instead we do this. If you were given this, so you have a QML application. It's got a big central list view, as these things tend to do. And then the customer says, well, I have 1 million items in there. It's supposed to scroll very smoothly. You've got 300 megahertz of tin. You've got no GPU. But I'll give you an FPU, just to make it interesting. Obviously, the last bit saves it, right? So at this point, I'm going home now. Yeah, most developers would not particularly embrace that kind of a challenge. How many of you would really like to have a go at that? Who thinks this is possible even? Well, the jumping is it's possible to jump off the damn thing. I'm talking about the QML problem. So who thinks this is possible? Okay. We're hiring. Talk to me later. Okay, so here's the solution. Actually, the guilty party again is in the room. Thomas, where are you? There he is in the middle there. Thomas McGuire came up with this. So you use a QList view, right? Subclass it. You put it in a proxy widget to be able to have it in the QML. This is obviously QML1. You throw away all of the painting, all of the delegate, pretty much everything. You do all of the list view painting. We're not talking about the item painting. We're talking about the list view painting yourself. No delegates, none of that. You sprinkle a little event filtering here and there, right, to catch all the right stuff, so you have it all under control. You manually position this list view on top of all the other stuff. No layouting, none of that, right? We didn't have that in the 70s. Chiseled the bits into stone. You use an abstract item model, obviously you need one for the list view. You then forget everything you ever learned about layering and abstractions, because these two talk to each other all the time in all kinds of ways, right? Forget about that API thing in the middle there. Pointers across, right? And of course, they need to, because they need to coordinate where we are and where the scroll bars are and which bits of data to actually load. You put underneath that big old cache where you keep a sliding window of things, which of course if you maintain the sliding window, you need to know what you're actually displaying. So this is highly specific to the problem. It's not general at all. It's not nice at all. It's not layered at all. But it scrolls smoothly with 1 million items on 300 megahertz. I kid you not. So next time you have to do something like that. Maybe forget about that computer science you actually learned at some point back in the day. Because it's about making stuff that works, right? Okay, it does work. The call grind, by the way, Vagrant, profiling tool, extremely handy. Without measuring, this is of course very, very hard. It was also very, very hard with measurement. Okay, and then you go take a bleach shower. Okay, so much for the interesting, Do you feel like having a beer at this point? Yes? Okay, so Mirko.
Thank you. About that beer, I'm only going to be about 50 minutes maybe, so you'll get there soon. So as Till has mentioned, he and I were old. We're working with Qt for a very long time, and when you're old, there are two things you do. One is you work less, if others do the work, and then because you have lots of time, you ponder. And isn't that true? Right. So you ponder all day long. Some of us decide to go back to university to have more time to ponder. And what I was pondering about was what causes all these things that we have just seen? What are the categories of change, maybe if you want to put it like that, that are inducing these challenges into our daily work? So let's look at the axis of change. And one I think is called chaos. And what I mean by chaos is that when we as developers, we do our best, right? We look at the problem, we analyze it properly, then we design an implementation, we implement it, we write the tests to it. We all do it by our best ability, but what we can't fully comprehend out front is every single detail of the problem. There will be something we overlooked. There will be something we just weren't able to foresee. And I think that foreground log, the first example that Till gave, is perfect for that, right? We've been using Qt for how long? We're almost at Qt 5, right? And there is no Qt foreground log in the library because we never thought it might be needed until somebody actually had the need. And if you think about it, there will be lots of examples for that where we are extending APIs, adding properties to QObjects at some point, making things scriptable, right? And of the three axes that I'm going to talk about, two can be handled quite well, and this is one of them. So what I mean by chaos is the completeness of an API of some module. Something that can be improving over time, again and again, like the foreground log. After years, we still have new ideas of how to enhance it. We're making QObject better for Qt 5, right? Without changing the functionality of QObject a lot. So our modules get more and more complete, and even with Qt 5, we have new ideas. But there's more. Like this can be handled, right? But there's more. There's confusion. Well, I chose that term mostly because it also starts with C. So
he's a university lecturer, you see.
So every time we thought we have something nailed down, right, they come up with a better way to do it, right? So our SQL module was fine. What's wrong with strings? And then the Java guys made Hibernate. Yeah. So we thought, we need something like that, and then Volker built a huge template library that makes it bearable. Now that he's done, the Ruby guys come up with Active Record, where they have versioning of the database in there as well. Now what, Volker?
Actually, I hate to tell it to you, but it does actually have versioning in there too.
Damn it. Give me a better example.
We should have rehearsed this, dude.
But you will see if you look at the APIs in Qt, but also in other libraries, that the same functionality has been implemented over and over again. Think of table views, right? Remember Qt3 table views? They were horrible, right? But they were a solution to the problem. And then we looked at this and made them better. And the SQL API is the same thing. We look at the SQL API that we have today. We would like to have something better. So it's not that we missed a part. It's that we like to have a better layer of abstraction, but we either didn't have the time to do it or the technology, and we're now getting there, right? So it's a different axis of change. It's the level of abstraction that we have reached, which is mostly incremental. You invest more time into this module, and you rewrite it one more time, and of course the answer to all engineering problems is another level of abstraction. But that's different from a missing feature like foreground lock. That's also dynamic over time. We come up with ideas over time, but still I think this can be handled quite well. But there's more. It's horrible. It's called disorder. Yeah, I couldn't come up with a term that starts with C.
2 out of 3 isn't so bad.
Yeah, I think. And also after C comes D, so I thought, you know.
No, after C comes C++.
Good point. And disorder is a bigger problem than the other two. When we talked about the REST-based interface to integrate with other platforms, what we actually admitted at this point is that we can't really abstract the problem away anymore. We tried. We tried. It was the understanding in Qt all the time, for example, that we abstract away the user interface layer. That we can use the same source code for everything, for all the platforms. And what we admit by choosing this solution is that that's actually not necessarily working anymore. So the change here, the axis of changes, is the viability of our abstraction layer. We have common understandings of what Qt should abstract away, and these have worked quite well in the past. Necessarily these things change as well, and some of our abstraction layers just start to make less sense. And one of them is the idea that you can write the same user interface in one piece of source code and apply it everywhere. But we see this becoming increasingly hard. And that means it's not that we can't do it from a technical point of view, it's that the idea of the abstraction starts to make less sense. So where we initially thought of missing features, things that we just overlooked, things that weren't that complete, and then in the second level looked at reiterating APIs to make them better, we now get to a point where we say, maybe I have to get rid of some old shoes and change the way we do things. And this is, for example, the idea of the user interface that is built natively, whereas the core of your application is written in Qt and exposes a REST API. So we've got 3 axes of change: chaos, confusion, and disorder, very heartening, right? But there's more. I then tried to see how the different axes of change affect us. Do you have a pointer? No, doesn't matter. I have fingers. And as I said initially, 2 of them, the 2 that start with C, incidentally, can be managed. Right? Chaos, the missing feature, we can add that. We recognize it's missing. We analyze the problem. We add the foreground lock. And we hope it makes its way into Qt. And we're fine.
If I may interrupt. The other thing we put into the abstract about boost serialization and Google protocol buffers, we figured those that don't show up to the talk because they're like modal view and threading, they'll come because of these other things. So sorry about that. But there's actually also a point there. We did research whether we would be able to come up with an abstraction where we use QDataStream to just transparently use either protocol buffers or QDataStream itself, or boost serialize or something. So that, the idea would be that QDataStream's fine as long as you're just talking to other Qt things, but you're mostly not, right? Let's face it. So if you're talking to something that's not Qt, you're going to use something like protocol buffers, or but then you have to use a different API. There is no, the DataStream API, which is both an API and an actual data format. It doesn't really work anymore. So maybe we need to separate the data stream format, which is the binary blob you write out to disk and you send across a socket, from the API, which is the stream thing, right? Maybe there is already an API for this and it's just I/O streams. Don't know. So we sat down, we thought, how hard can this be? We'll just write, a proposal for a nice API that just encapsulates this and it's all transparent.
I think we also said it takes half a day, right?
And we said it takes half a day because if there's one thing you never get any better at, it's the how hard can this be approach to software engineering. So, and to be quite honest, we failed. We just couldn't get it done, which is, of course, only due to lack of time and unavailability of very old single malt scotch. So yeah, we didn't manage. So if you have a good idea for this, I do think it's something that is missing in Qt, this kind of idea of an abstracted transport. There's dbus, but that's not really the same thing, is there? There's SOAP, and it's a little, yeah. So yeah, if you have an idea, that's a nice little homework project, I guess.
Right.
So you have an idea?
Well, there's something like
No, you can discuss that later.
Okay. I'm sorry, I'm being chastised here. Back to our lecture.
Yeah, thanks for interrupting. I'll backtrack and start over with that slide. So I explained how we can control the axis of chaos, right? And the axis of confusion is also not that hard. It's just what we do as engineers. We go back to our module, we look at its shortcomings, and we abstract it one level up. Make a better SQL module, make better streams. That's all incremental improvements still. But the disorder part, the part where what we're abstracting changes, that is quite hard to handle, right? And the examples I gave here are different UI platforms. Try to find the common ground between Metro and Android. It's hard. And our assumption was, as long as we have QPainter, we can abstract away the UI. We can implement it in Qt. Yeah, one source code, compile and run everywhere. I don't think that's going to work because it's not about the source code, it's about the paradigms of how the UI is used. But I thought this slide doesn't really visualize what I was trying to say very well. So I thought of another way. So this is Qt. And in the old days. Is that not obvious? All right. Why is this Qt? Because until Qt 4, and as long as we were on desktop platforms and maybe some mobile, our common body of functionality that we could abstract away made up the majority of the features. Right? The big circle, the body of the pig, that's what we could abstract away. And then there were some mundane details, right? Like native widgets on Macs. It was like a little, sticking out of the abstracted away body. But we could still handle them. Well, of course, you made custom code for Macs, fine. And then there were more mundane details where you needed access to like native events, and those are the ears that are sticking out, right? Even more ugly code, maybe C code, GTK code, Objective-C sometimes. Software, yeah.
There was no reason to be mean.
I didn't want to be mean. I didn't want to be comprehensible examples. So the more specific things got, the rarer and fewer they got. So the little ears of the pig were that was the Objective-C code and the native events and stuff. And I think that over time, especially pretty much now with Qt 4 approaching, things have changed. All right. Now we still have a large body of abstracted away functionality, and chaos and confusion is right in here, you can see that. But we now have pieces of functionality that we need sticking out and being still very substantial, like the ears. So this would be like the Android platform, and this would be Metro. I couldn't draw a third ear. That would have looked wrong.
Uncounted to 3 is hard.
Yeah, but you get the point. So the disorder axis basically means that we will have to accept that some things just can't be abstracted that easily and still be accepted by the user. I mean, that's of course you can write the same UI on all these platforms, but that will not be very successful. So if you ask me what changes with Qt, that is it. We're changing from we can abstract away everything to we can abstract away the things that we can control, chaos and confusion. And we will have to accept that we have to interface with native platforms, with services on the web that talk not QData stream, and other things like that. Which means that increasingly we'll probably see Qt code being more of the middleware layer, as if you have an API, a program that exposes a REST API, and less of the thing that actually implements the user interface, for example. So, and if you think about the topic of our talk, where we said using Qt in unexpected ways, I think that the disorder axis is kind of the unexpected way. Because I don't think that we all expected that the idea of abstracting away the UI will become less viable, right? And so when we talk about making an application that exposes REST and just does the core of the functionality, that's unexpected for a Qt developer. Thank you.
All right. Thank you very much. Before we go to the beer, we could do questions, but that would mean that we need to answer them.
Please.
So instead, I propose we share war stories, because we can then just kind of slide into the beer drinking. So if anybody has anything particularly they'd like to share, some deep, dark secret in their code that they never thought they would be willing or able to show anybody ever, or if you have a question, raise your hand and I'll give you the microphone. Yeah, James. Oh my God, I'm scared.
Is this going to be about Objective-C?
No.
Okay.
Why not? You know this too.
We had some clients that wanted to support Mac but didn't want to rewrite their code, so they wrapped Qt in MFC, the MFC API.
Beautiful, eh?
We declined that work, that project. It was too horrible. So like basically wine written in Qt.
Okay. Yeah, that's pretty bad. Okay.
Can you now come up with something that was uglier than that, please?
Are you sure you can't?
Come on, it's a challenge.
Martin.
Oh, Marty.
Well, this is I've done this with a colleague together more than 10 years ago, where we were supposed to write a terminal emulation which runs on any kind of desktops and which connects to big host servers. And we tried pretty hard to get a complete terminal emulation, which should not be that difficult because there's a standard for that for VT100, VT52, and so on. But we figured out that the applications that Bang was actually running were not always working perfectly. And in the end, because we couldn't do it really, we figured out that it's easier to write a complete emulation of an original VT100 terminal, including the CPU, and emulate everything. Which is well, it's the original terminal was a 4-bit CPU. It was the very first Intel 4004, and so doing actually the complete emulation turned out, and running the original BIOS code turned out to be much smaller, much faster, and bug compatible.
Yeah. How hard can it be? Here, there's another story.
I'm not sure this can keep up with that, but this is not from me, but a friend of mine who works at Google has told me that Google Earth is actually mostly C code that is used both natively to compile Objective-C, C++, and on Android. So it's the same code base running in C, but it's interpreted as Objective-C or C++ or C as it, what the platform depends on. So that's pretty ugly as well, I think.
No, that's cross-platform, right?
But they're Google, they're allowed to do such things, right?
We would like to hear a story from the ears.
Yeah. Bogdan? No, Bogdan isn't here, the Android guy. Oh, by the way, I can take this opportunity. The dude who contributed Necessitas, the Android port, to Qt project is my personal hero. I think he needs to have a big, big recognition in the community because that is an awesome piece of work.